Welcome guys to our fourth video on vectors. We now begin to look at unit vectors, so that should be 5.8. So 5.8 unit vectors. Okay, unit vectors. Okay, there we go. Unit vectors. So unit vector by definition is just a vector of length 1. So a vector v, okay, of length 1, of length of magnitude 1 is called, this is what we call a unit vector. Okay, so a unit vector basically we had unit 1, so to mean that these vectors have got unit 1. So we've got, so there are so many vectors out there with that length, but then we can always come up with the standard unit vectors. So by standard we mean that these unit vectors are probably pointing in some particular standard direction. So we've got standard unit vectors. Okay, standard unit vectors. So if for example, if we have the x, y, z space, or three-dimensional space, then we'll have one in the x direction, we'll have y in the y direction, and we'll have one in the z direction. So the one that's along the x-axis, the one that's along the x is the unit vector I. So the notation we use is you put an I, and then you have to put with a heart. So it's not a dot, but it's a heart. So I is a vector with components. It only has 1 in the x direction and 0 in the other directions. Okay, so then we have the unit vector in the y direction. We are going to call it that should be j. So j with a heart. So j with a heart. So it has got components: 0 in the x, 1 in the y, and 0 in the z. So the one in the z has zeros everywhere apart from the z. So this we're going to put the k unit vector. So 0, 0, 1. So that so these are the standard unit vectors we have for the xy plane. Just to give a pictorial representation of what we have here in terms of okay, so we can draw the so if we have okay, so let's say this is our x-axis, let's say this is our y-axis, and let's say this is our z-axis. Okay, so if things as follows, then this means that basically we have a vector in the x direction of unit of length 1, so that will be our I. We have a vector along the y direction of length 1, that is our j. We have a vector in the z direction of length 1, that is our k. So that's basically what we have in terms of trying to represent it. Okay, so it turns out that any vector in 3D so can be written as a linear combination of the unit vectors. So if we have any vector, so any vector, so if we have any vector, so let's get some vector v with components v1, v2, and v3. So we have some vector v in the x, o, y, z space. So we can write this as can be written as a linear combination. So by linear combination, which means I can multiply this by scalars and add them, can be written as a linear linear combination of the unit vectors, okay, of the standard unit vectors of I, I, j, and k. So one thing we need to note is that when you talk about linear combination, all we are saying is that I can get the components, multiply them by these unit vectors, and then add them. Then what I get in that particular case is a linear combination. So linear combination is just basically multiplying by scalar, and then also adding of vectors. Remember, we looked at the two important properties. We looked at addition of two vectors and also multiplication by scalar. So whenever you do those two operations, what you're doing is a linear combination. Okay, so it can be done as follows. So as follows. So we have v, which is equal to v1, v2, v3. That's what we know for now. So how do we write them as a linear combination? So I know is that, okay, what if I do this? I take the other components to be zeros. Then I take also the other components to be zeros. Then for the y part, I remain with that guy there. What if I also do that for the z part, so that I have that? So that, of course, then in these positions I only have zeros. So when I add to that, I'll still get that vector there. Okay, so but then I know that. So this vector here, if I multiply it with so if I factorize the v1 from here, so then I get 1. Of course, v1 is a scalar quantity, so you can factorize by those properties of operations. So 1, 0, 0 plus factorize your v2, which is a scalar quantity because it's just a component. So you remain with that vector. Then factorize your v3, you remain with that vector. But of course, then you realize that these are the standard unit vectors we are looking at. So actually, you can actually write v in form of v1 times I. This is I plus v2 j plus v3 k. Okay, so which means if you are given a vector in the component form, you can easily convert this in form of unit vectors, in form of standard unit vectors, by just multiplying the components by their respective unit vectors, and then adding them. Then what we get is a linear combination, and that will be our vector in terms of the standard unit vectors, instead of the standard unit vectors. Okay, and so v1 is the scalar quantity, is the ith component of the vector v. v2 is the jth component, and v3 is the kth component. So generally, if we are given another vector, so for some vector, let's say pq, which is x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. So remember, if this one is ones and this one are the twos, then we can always subtract the coordinates, then we get the components, right? Okay. Maybe another property we need to look at, if just some general remarks. So some general remarks. If v is not equal to 0, then its length is also not equal to 0, and you can show the following. Okay, if we put quantity 1 over the absolute value of v, which is the magnitude of vector v, okay, times the vector itself. So if we divide a vector by its magnitude, we actually get and then we get the magnitude of that particular vector. What we get is 1. So which means this should be a vector. Then which means this guy v, okay, over v over the magnitude of v is a unit vector. So how would we get a unit vector in some particular direction? If you have got if given any other vector, then you want to find the unit vector in that particular in the direction of that particular vector. So all you do is divide that vector by its magnitude, then you get a unit vector. Okay, because by doing so, then you are getting a vector of magnitude 1. Remember, by definition of a unit vector, it must have a magnitude of 1, but the direction might be anywhere. Okay. Okay, so that's what we have. So if at all the vector doesn't have a magnitude of 0, then you can always have this is always true, provided we have that. Okay. So an example. Okay, 5.9. So example. So let's find a unit vector. Find a unit vector u. Okay. Okay, let's use hat. Okay, let's find a unit vector u. So with the hat, say the unit vector in the direction from P 1 0 1. Okay, this is circular bracket. This is P1 to P2 3 2 0. Right, so let's find the unit vector in that particular direction. So the first thing we have to do is first of all find that particular vector itself. So we first find the vector itself, P1, P2, we find that vector. Okay, what do? We in terms of component, we subtract the components, so minus 3. Okay, this should be, oh, this is positive 3. Okay, so 3 minus 1 multiplied by the I, then we have 2 minus 0 multiplied by the jth component plus 0 minus 1 multiplied by the kth component. So if we do so, we end up with some vector 2i with the hat plus 2j minus k. Okay, so that's what we end up with, but then we also need this magnitude. So the magnitude of P1, P2 as a vector, we Pythagoras theorem, we just square these guys and we get a square root. Okay, this will give us a 4, 8, 9, so we get value of 3 as a magnitude, so which means the vector u, so the unit vector u in the direction P1 to P2 is given by P1 by that definition. By this definition, we divide the vector by its magnitude. We get a unit vector in that particular direction. Okay. Okay, we get a unit vector in that particular direction. So what do we have finally? So we have 2i plus 2j minus k. So remember, don't forget the hats, so that the unit vectors divided by throughout is 3. So which means we can now divide throughout. So we have 2 divided by 3 I plus 2 divided by 3 j minus 1 over 3 k. So you can actually try and show that the length of that vector, the magnitude of that vector is 1. So that is the unit vector in the direction P1 to P2. So that's how you, if you're given any vector, you find the unit vector in that particular direction. So all you do is just divide, then you get whatever you want to get. Okay.